So we all learn the scientific method in grade school. Even though we learn at an early age that the scientific method is the process to use when we want to test ideas, we don't often practice it. Like anything, the use of the scientific method is a way of thinking that requires practice. It can be used for both personal and professional development and improvement. To recap our early science lessons, the scientific method follows some basic steps, plus a feedback step to help us determine what to do next. The steps are: first, make an observation. Once you notice something that intrigues you, do a bit of research to see what others have found. Compare their methods and context to help you refine your thinking. Next, form a hypothesis. Make this as specific as possible. Remember, it has to be testable. Once you have a hypothesis that is specific enough to be tested, run an experiment. Again, be as specific as possible about the test of change. Who's doing it? How are they doing it? And for how long? Once you've run a test, evaluate the data and draw conclusions. Was your hypothesis supported? If not, how would you modify your hypothesis and test to help continue your learning? Finally, report your results. Great research can be replicated. If someone else were to run your experiment, would they get the same results? This is how we advance our knowledge base as a society. The scientific method is often used in the natural sciences, so your chemistry, physics, biology, as well as in disciplines like psychology, sociology, and engineering. Because of its use in these fields, we might think that the method requires extensive data planning and a background in statistics. But the scientific method shouldn't only be used to determine universal laws of nature. While the scientific method is largely responsible for the rapid increase in our understanding of the natural world over the past few centuries, it's been slow to enter the world of politics, business, and policy, where our intuition for human behavior often makes us think that we can skip over following a systematic approach for understanding a particular situation. But if we've learned anything from science, it's that the most plausible explanation is not necessarily correct. Adopting a scientific approach to decision-making requires us to test our hypothesis with data. There's tremendous value in running small experiments following the scientific method to help us better understand and improve our daily lives. Using the scientific method in business enables us to problem solve, it helps with decision-making and achievement in strategic objectives. As we learned in our lecture on the history of operational excellence, Frederick Taylor was one of the first to treat management and process improvement as a scientific problem in the early 1900s. He detailed this approach to his groundbreaking book, The Principles of Scientific Management. He later became known as the father of scientific management and helped set the stage for pioneers like Lillian Gilbreth, Henry Ford, Seiichi Toyota, and Edwards Deming to evolve our understanding of process improvement. While these pioneers have done so much to forward our thinking about how to approach business and operational problems with more rigor, we still have a long way to go in recognizing the opportunities for using this approach regularly in our work. Considered by many to be the father of continuous process improvement and the quality movement, Edwards Deming introduced the concept of PDCA in Japan in the 1950s. In the 1980s, he brought the thinking to the American auto industry and quickly became one of the most influential and sought-after quality and management consultants, teaching the thinking and process across industries. The PDCA model is grounded in the scientific method and in psychology. Beyond just taking a more scientific approach to problem solving, the process and principles focus on personal and professional growth that we experience when we learn and succeed in overcoming obstacles. Deming's legacy has changed the way we think about improvement, learning, and leadership. Let's walk through exactly what we mean by PDCA. The cycle begins with the plan step. This involves identifying our goal or purpose, formulating a theory, defining success metrics, and putting a plan into place. In short, you define what you expect to do and what you expect to happen, and this is where we form our hypothesis or prediction. These activities are followed by the do step, in which the components of the plan are implemented, such as making a product. This is usually a prototype or something that can be tested relatively quickly. It could be a new process or something as simple as moving the location of a piece of equipment. Here, you are testing your hypothesis by running the process according to the plan and then observing closely. Next comes the check step, where outcomes are monitored to test the validity of the plan for signs of progress and success, or problems and areas for improvement. You compare the actual outcome with the expected outcome. The act step closes the cycle, integrating the learning generated by the entire process, which can be used to adjust the goal change methods, or reformulate the plan altogether. We also often refer to this as the adjust stage, as that's most often what's required. You standardize or stabilize what works, or begin the PDCA cycle again. These 4 steps can and should be repeated over and over, which formulates the basis of continuous process improvement. Deming often made a point to say that all the planning you do today reflects everything you've accumulated in terms of understanding up to this point. But that understanding is imperfect and often has a lot of unconscious assumptions built into it. So you really need to plan to do something and then compare that experience of the doing with the planning to see where there are gaps and then act against those gaps to improve. This is where the growth mindset comes in. The first few times you deliberately use the PDCA cycle process, you might feel discouraged, as our hypotheses about what will happen after we make a change may or may not have worked as we had planned or hoped. And while most of us have been conditioned to see failure as something that's terrifying, like failing a grade or a test, it's anything but bad. It's the secret sauce to learning and improvement. Whenever you hear the word fail, think first attempt in learning. Again, it's all about the growth mindset here. If everything always went as planned, we'd have no opportunity to learn. We can use all of those gaps between what we expected and what actually happened to help us refine our understanding of the original problem, the need, and to help us find opportunities for improvement that we didn't recognize when we started. The PDCA cycle is really just a learning cycle. Too often, we don't take the time to compare our original hypothesis of what we think is going to happen against what actually happened. This leads to one of a few things. We can either mistakenly believe that our change or intervention worked when it didn't. We see this a lot, and often ends up with management putting new systems, processes, and products in place that continue to create obstacles and frustrations for employees and customers without ever really providing additional value. Because we're often so busy and so overwhelmed, these subpar improvements will remain in place for many years, sometimes decades before they're revisited. Another potential outcome of not using the PDCA cycle process is just scrapping our idea altogether. When we recognize that there's a problem or that something didn't go as planned, it's frustrating, right? It took a lot of time and energy, and let's just scrap it and move on. No, that is not the growth mindset. We need to remember that the PDCA process is a cycle. Lastly, one of the traps that we can see teams fall into is what we call the Dudu Cycle. We plan, and then we try things, right? If it didn't work out as planned, we quickly plan and do something different. We need to take the time on the back end of the process. This was why Deming changed his use of the terminology over time from PDCA, which we know as Plan, Do, Check, Act, to PDSA, which he refers to as Plan, Do, Study, and Act or Adjust. He realized that people were literally just checking, yep, it's done, we ran the experiment, and they would move on. Instead, he wanted to emphasize this critical step and started referring to it as study. So you'll hear me and others say PDCA, PDSA, we use them interchangeably, which is fine. We just want to remember that after a test, instead of just checking whether something worked or didn't work, we need to truly study the data and talk to those involved to understand the challenges. This is the study component. When we do this well, it helps us determine the biggest obstacle we need to address on our next go around. So this completes the cycle of learning, takes us into the next. This is where we really start to make traction and identify tests of change that are more likely to be successful. Rarely are we going to see the desired impacts right away. We need to refine our thinking and use small, rapid experiments to help us test. Again, this is easier said than done, which is why we often suggest doing improvement work under the guidance of a coach. Having someone in your corner to ask you questions about your improvement cycles will force you to more clearly articulate your hypothesis, your test of change, the resulting data, and your next steps. If you're attempting to just keep track of this in your head, you're not doing yourself or your team justice. Write it down and hold yourself accountable for cultivating a growth mindset by working with a team and a coach. Now, sometimes we're in a big rush to fix something. We like to refer to this as firefighting, which is a reactive strategy and usually doesn't help move us forward. This might entice us to think about how we can quickly run through the PDCA cycle. Usually this encourages us to think about how quickly we can run a test of change, or the D, the doing part of the cycle. We've got a hypothesis, now let's figure out how quickly we can design a new product or process to test that. This is dangerous territory and usually leads to a short-changed PP Dudu cycle. Instead, what if we plan better? So hear me out. Rather than saying, I have a feeling of how this is going to play out, work to construct a hypothesis that explicitly states all the actions to be taken and why we believe this approach will work. This requires you to call out your existing assumptions. Remember, Deming often reinforced that our hypothesis is designed based upon our current understanding and assumptions. As my good friend Tony Benner often says, we can only see as far as our flashlight shines. Our understanding of the situation should drastically deepen throughout a few PDCA cycles. The rigor of declaring not only our actions and tests of change, but our reasoning enormously increases our ability to study the outcomes and make logical adjustments, which increases the likelihood of success after a few rounds. We are all desperate to get better as fast as possible, and the knee-jerk reaction is to quickly pull a plan together and make a change. Remember, PP-doo-doo is not great. This is where we want to slow down to go fast. You've got to slow your thinking. Make it crisp and be disciplined in explicitly stating your hypothesis and studying the data after a change to determine what obstacles still need to be addressed. You need to trust the process and remember the growth mindset. And instead of looking at setbacks as the end of the road, think not yet. The scientific method focuses on preparation for and evaluation of an experiment. If we don't approach our improvement efforts with rigor, we miss the opportunity to learn and make significant and sustainable change. This method requires us to go see where the work is being done, make observations, and collect data to inform our ideas for experimentation and determine whether or not they were effective. The PDSA method is ongoing. What we learn from one small experiment can and should inform our next. This, again, is continuous improvement. A great tool for practicing and documenting the scientific method is the Pdca Cycles record. It helps you to be explicit in your hypothesis and intervention, being really clear about what you're going to do and what you think will happen as a result, as well as then reflecting on what actually happened and what you'll do next. The process will be easier to manage if you can scope down your experiments to be something small, manageable, and measurable. As you can see, this tool helps do this by first being very clear on the process you're focusing on. It also makes you identify each member of your team and the coach that will help ask clarifying questions along the way. In the first column, clearly identifying the test of change along the way with a date and who and how it'll be performed. The next column forces you to think really clearly about what you think will happen once you take that step. Afterward, then you list what actually happened and what was learned. Let's practice with a simple example. So I often work with health systems to improve care delivery, acting as a coach for small, multidisciplinary teams. This is an example from a hospital I worked with a few years ago. There was a problem with the supply chain in the operating room. Too often, supplies would be requested for a procedure and would never be used. So after each case, there was a big effort to return everything that was unused. Many times these items weren't correctly logged back into the system, and it created big issues with knowing what was in stock at any given time. Plus, it was expensive and time-consuming. Nursing leadership wanted to partner with the surgeons to get a better idea of what they truly needed for each case. Things that were requested just in case could potentially be available nearby without having to have them formally added to the case cart for the operation. Their original hypothesis was that each surgeon had two categories of supplies, those that are truly needed and those that are requested just in case. So their plan was to track what was used after each operation and have a conversation with the surgeon afterward to see which category the unused supplies fell into. Their hypothesis was that this would reduce the number of items on the pick list, which is essentially the shopping list the surgeon puts together for a particular case. A further built-in assumption was that by reducing the number of items on the pick list, the surgical team could prepare cases faster, spending less time afterwards on restocking, and the inventory counts would be more accurate, which should reduce the chances of those dangerous stockouts. So that's a lot of assumptions packed in there. But again, it's important to be explicit with our assumptions. There were a number of additional assumptions that they didn't even realize they were making that the process really helped uncover. So let's see what happened after running an experiment of talking to just one surgeon after each operation over the course of a day. As you can see here, the team identified a number of items that were frequently not used. In one case, neither the nursing team nor the surgeon even knew how or why an item was included on the pick list. In another case, they found that the item that was picked was incorrect. The catalog number on the pick list and the item were different, but the name of the item was the same, which opened up a completely new set of problems to investigate. They found that due to a stockout, another supply had been used, prompting additional questions around the stockout. They also found that one of the newer models of the gastric tray contained a tube and a syringe, so the to-me syringe requested was no longer needed, even though they had been including them both on the case cart for months. While the hypothesis was partially supported, it did help to slightly reduce the pick list. It raised a number of new questions regarding catalog numbers, problems with how SAP was reordering supplies through the organization's MRP system. Moreover, it reinforced that this process was eye-opening and that it needed to be continued. Remember, it's a PDCA Cycles record. We need to keep going. At this point, you might be thinking, whoa, there's a lot that needs to be worked on. How do we move forward within the act or adjust phase? Here, it's important to pick just one obstacle to address. Which one do you want to choose? You could run another experiment with another surgeon to further remove unused supplies. You could work to fix the discrepancies with the catalog numbers. You could focus on SAP and the automated reordering process. Every day, the team picked one area to address based on what they had learned yesterday. They had a clear cover folder hung on a wall where they all kept all of their PDCA Cycles records in order. Over the course of 2 months, the team had reduced the pick list in bariatric surgery by almost 20%, saving the organizations hundreds of thousands of dollars and reducing unnecessary inventory, and addressed some of the inventory tracking and reordering issues, eliminating those dangerous stockouts. The best part of this process was seeing the growth of the team, though, both professionally and personally. Their approach to their work was far more rigorous than ever before, and they felt really proud of their accomplishments. After seeing the success the bariatrical surgical team had, several other service lines wanted to make the same changes. But in order to reap the same benefits, these teams could not just copy the changes. They had to follow the process because each service line has unique challenges and obstacles to overcome, which can only be uncovered through systematic experimentation. Deming was critical in cultivating Toyota's approach to continuous improvement. They took the principles of the scientific method and PDSA and utilized them across the organization to achieve stretch goals. Their approach to goal setting and consistent evaluation of the current condition against the target condition and utilizing PDSA to overcome obstacles was described in detail in the 2009 book Toyota Kata. A kata is a small, structured practice routine that we'll be talking through more in more detail in another lecture. Toyota's approach to continuous improvement has evolved over time through the use of daily reflection and experimentation toward a goal. And this is in many ways the foundation to lean thinking. Later on, we'll see how the scientific method and PDCA cycles are critical to helping startups test ideas and prototypes, creating what's referred to now as validated learning. We'll talk through how agile project management approaches like Scrum's control process is essentially PDCA with different labels. We'll also see how design thinking uses a similar process to iteratively test new ideas, pilots, prototypes, and get ready for trials. PDCA and the growth mindset are critical components to operational improvement, strategic growth, and research and design. Instead of waiting for your next opportunity at work, try practicing with the PDCA Cycles record at home. You may just uncover some subconscious assumptions that can transform your relationships in your day-to-day life. It's worth a try.